Alright guys, welcome to this page of the notes, and we're going to go ahead and do another example problem where we're going to use Descartes' rule to find all possible combinations of positive, negative, and imaginary roots for this polynomial. And I apologize, there is a typo in this problem. Please, you may have already recognized that I have a negative 4x squared and a positive 6x squared. Just go ahead, scratch out that positive 6x squared. The polynomial we're going to do this problem for is 2x to the 5th plus x to the 4th plus 3x cubed minus 4x squared minus x plus 9. All right, I'm so sorry about that. I don't know how that snuck in there. Anyway, we're going to do it for this polynomial. Ignore that positive 6x squared, and here we go. Let's jump right into it. So, to find the positive real roots, I count the number of sign changes. That's what Descartes' rule says. Positive to positive, no. Positive to positive, no. Positive to negative, there's 1. Negative to negative, no. Negative to positive, there's another one. So, I have 2 positive real sign changes or less than that by an even number. We'll get to that in just a second. Then, to find the negative real roots, I need to plug in a domain value of negative x. So let's go ahead and do that. We're going to have 2 negative x to the 5th plus negative x to the 4th plus 3 times a negative x cubed minus 4 negative x squared minus a negative x plus 9. And again, a little bit of real simple algebra here to go ahead and take care of this. Negative number to an odd power is going to be negative, so this now becomes a minus 2x to the 5th. A negative number to an even power is going to be positive, so plus x to the 4th. Negative number to an odd power is going to be negative. Negative times a positive is negative, so minus 3x cubed. A negative number squared is going to be positive. Positive times a negative is negative, so minus 4x squared. Negative times a negative is now going to be positive plus x. And then I got my plus 9 on the end. And we go through and count the sign changes for this polynomial to find my negative real roots. So negative to positive, that's 1. Positive to negative, that's 2. Negative, negative, no. Negative, positive, that's 3. Okay, so here we go. Let's go ahead and write our tables then. Here's what I've got. This is going to be real positive roots. Right? And I could have at most 2. But Descartes' rule says I could have less than that by an even amount. Well, the only other option, 2 minus 2, which is the smallest even number, gets me 0. So my only other option is 0, 2 and 0, right? Okay, my real negative roots, and this is going to be a fun one, because I count them up and I see that I could have at most 3. I could have at most 3 real negative roots. Or less than that by an even amount. So I must subtract an even amount from 3. Well, the smallest even amount I can subtract from 3 is 2. And 3 minus 2 gets me 1. So my only possibilities are 3 and 1, right? Because 3 minus an even amount, which the only even amount that goes into 3 is 2, gets me to a 1. So I don't even have a possibility of 0 in this case, right? Because if I were to subtract 2 from 1, that give me to negative numbers, and we're not going to have negative, you can't have, right? It doesn't make sense to have a negative number of negative real roots, right? If you have a negative real root, you have to be able to count the number of real roots you've got. So it's got to be a positive number, and 3 and 1 are the only options in this case, because it's got to be 3 is my max, and then it has to be less than that by an even amount. And again, the smallest even amount that goes into 3 is 2. So 3 or 1, those are my possibilities. So now that I've got my tables, we are going to set up all of our possible combinations right here. Again, systematically work your way through this. I could have 2 positive and 3 negative. 2 positive, 3 negative. I could have 2 positive and 1 negative. 2 positive and 1 negative. And that's it for 2, right? 2 and 3, 2 and 1. That takes care of all those. So now I go to 0. I could have 0 positive and 3 negative. And then I could have 0 positive and 1 negative. And that takes care of all of those possibilities, right? That's it. That's all I've got. So those are all my possible combinations for positive and negative real roots. Now, to figure the rest of it out, we just jump up to the polynomial that you were given, use the fundamental theorem of algebra, which tells me it's a 5th degree polynomial, which means all possible combinations must sum to 5. So this guy's got to sum to 5, 5, 5, and 5. All those have to sum to 5, and so let's go ahead and do it. 2 plus 3 is 5, so I would need 0 imaginary. 2 and 1 gets me 3, which means I would need 2 imaginary to get to 5. 0 and 3 is 3, so once again I would need 2 imaginary to get me to 5, and 0 and 1 is 1, which means I would need 4 imaginary in order to get me to 5. And once again, we've used Descartes' rule to list all possible combinations of real, positive real, negative real, and imaginary zeros. All right, guys, head on over to the next page of notes, and we'll do a little bit more work with imaginary zeros. So I'll meet you on the next page.